Hi everyone, welcome to our 3.3 lesson. We are in our notes today looking at the cosine law. And up till now we've dealt with the sine law to find an unknown side length or an unknown angle in an acute triangle. And now we're going to learn a different law that we have that will help us to find a side length or an angle if sine law is not does not work for us. So if we can't use sine law, we don't have the right information, we will be able to use cosine law. We're going to start just looking at where cosine law comes from. We're not going to have to prove cosine law in this class, but I want to give you a background on how it's developed, and it comes from two things. One is that in a right triangle, we have a primary trig function for an angle. So for example, if this is angle theta, and I have my opposite side over here across from my angle, my hypotenuse is always across from my right angle. And the leftover side here, which makes one arm of my right angle, is called my adjacent side. And you might recall that if I knew my adjacent side here, okay, and I knew my hypotenuse, I could figure out my angle because the cosine of an angle is equal to the ratio of the adjacent over the hypotenuse. This is one of the three primary trig functions. So we have sine of an angle, which is opposite over hypotenuse, cosine of an angle, adjacent over hypotenuse, and then there's also the tangent of an angle, which is the opposite over the adjacent. But cosine law comes from this relationship. So the cosine of any angle is the adjacent over the hypotenuse for a right triangle. And again, our acute triangles can be divided into two right triangles, and so this is where cosine law is derived from. The other thing that's true of a triangle, a right triangle, is that here's my hypotenuse. The square of the hypotenuse, okay, the square of this side length here, the hypotenuse, is equal to the sum of the other two side lengths squared. So on a right triangle, if I call this A and I call this B, and we call our hypotenuse side length C, this is Pythagorean theorem. And on a right triangle, this is true. A squared plus B squared is always equal to C squared. So if I have a right triangle where I know two out of the three sides, I can use Pythagorean theorem to solve the last one, where C is always the hypotenuse. Okay. So from these two different laws, the primary trig function for cosine of an angle and Pythagorean theorem, comes our cosine law. And you're given cosine law, and it's on the next page of your notes, and it's derived from both of these. And it can be written three different ways. So for a triangle that is not a right triangle, we have the following law, and it looks like this. Let's go ahead and label our triangle. So let's call this triangle ABC. I'm going to label each of my vertices here A, B, and C. Okay. So that gives me a name for each angle. So capital A is referring to angle A right here. Okay, and capital B refers to angle B, and capital C refers to the angle at vertices C, so angle C. And across from each angle, I would label my side length. So A is across from A, just like we would label it for sine law. Okay, and across from B, angle B, is our side length B, and we use small letters to represent side lengths. And across from C is side length C. So there's an acute triangle, and cosine law tells me this. If I was solving for side length A squared is equal to the other two side lengths squared and added together. Subtract 2 times side length B times side length C times the cos of angle A. So remember, capital letters, when we're looking at sine law and cosine law, capital letters represent angles. So this is angle A. And this same law can be used for any of the other two side lengths. So for example, side length B can be solved, okay, by using B squared is equal to the other two side lengths squared minus 2 times the product of those side lengths times the cos of that angle opposite to it. So the cos of angle B. And again, the same thing can be written for the other side length C. So when do we use the cosine law? Well, we use the cosine law when we can't use sine law. And there are two times when we can't use sine law. The first one is if we don't know any angles at all, then we definitely can't use sine law. So if we have 3 side lengths but no angles, we call this a side, side, side situation where I know 3 sides and I don't have any angles, so guaranteed I can't use sine law. I have to have one angle at least to be using sine law. However, if I know all 3 side lengths, I can use cosine law and I can solve for an angle. Okay, because cosine law uses all 3 of those side lengths, and I would be able to solve for the one unknown angle, and then I could use it again. Or at that point, I could use sine law to find another angle. Okay, the other time we can use it is when we have a side and another side, and the angle that we have is a contained angle. So this is when we have a contained angle, meaning it's in between 2 side lengths. This will allow me to use cosine law. I know I can't use sine law because I do not have this side length across from the angle, so I don't have a side angle relationship, which means I can't use sine law. But I could use my cosine law here because I could solve for this unknown one right here. Okay, that would be my unknown side length. I have the angle opposite to it, so I can take the cosine of that angle, and I have the other 2 side lengths. And this is called a side angle side relationship. So side angle side, where the reason the A is in between, this is a contained angle. So it's sandwiched in between 2 sides. Okay, and those are the 2 times that we'll use cosine law. Let's do some real examples now and practice this. So our first example here, it says find the missing side length in the acute triangle below, and here's what we're going to be given. This is going to be a side angle side problem. So we're going to be given that the side length over here is 1.0, let's say meters, okay, and we have a contained angle of 59 degrees, and we have another side length on the other side that is 1.5 meters long, and we're looking for this opposite, the third side in the triangle. Okay, so the first thing you would want to do is, even if you are not working, I mean, right now we're looking at cosine law, so it's obviously we're going to be using it, but if this was just a question that you were given on a test or quiz, you would think to yourself, can I use sine law? And we see that we don't have any side angle relationship here. We have no side opposite an angle that we could use as a ratio. So we can't use sine law. This is a side angle side problem where we have a contained angle, which tells me that I have to use cosine law. Okay, so let's go ahead and label our triangle so that we can figure out what cosine law, which one we're going to use, okay? And so for this, to make it easy, I'll label my triangle ABC. So let's call this one A here. And we'll call this B and call this C. And now let's label our side lengths. So across from angle A is the one that we don't know. So side length A is what we're going to be looking for. And across from angle C is 1.5. So there's my side length C. And opposite angle B is 1. So there's my side length B, opposite from the angle. Okay. So what am I looking for here? I want to find side length A. Okay, and so I'm going to use the cosine law that lets me solve for A, and I have angle A, so it's going to look like this. I'm going to use A squared, okay, is equal to the other 2 side lengths squared, so B squared plus C squared minus 2BC times the cosine of angle A. It's always the angle opposite from it, from the side length we're looking for, okay, that we're taking the cos of. So let's go ahead and substitute in all the information that we have here. So we're going to say a squared is equal to b, which is 1.0 meters squared, plus c, which is 1.5 meters. I can leave my units out just for the moment to simplify my work. Subtract, okay? Notice that 2bc times the cos of a is all together. So this is a product. We're going to be multiplying 2 times b times c times cos of a. So I can put maybe some big brackets around this, okay? And this is going to be 2 times b, which is 1.0, times 1.5, which is c, times the cos of angle A, and angle A is 59 degrees. Okay, and let's go ahead and do this math together. So 1 squared is still 1. Okay, 1.5 squared is 2.25. Subtract, and I want to do the math inside there. 2 times 1 times 1.5 times the cos of 59 is 1.54511. I'm going to leave a few decimal places. Don't round right away. Leave at least 4 decimal places, okay? Just so that you get an accurate answer. You can round at the end. So let's simplify this now. We have 1 plus 2.25 minus 1.54511, and we get 1.70489 if I keep the same number of decimal places here. And that's the value of side length A squared. So I just need to square root this now in order to get A. So A is equal to the square root of 1.70489, and that's 1.3057. Again, if I leave it to 4 or 5 decimal places. Now it's okay to round. Let's go back and look at our other side lengths. They're all given to 1 decimal place to the nearest tenth of a meter. So let's go ahead and be consistent and round it there. So A is equal to 1.3 because 0 is not big enough to round up, meters. Okay, and there's my side length A. And so I could come back and put that here into my diagram. Okay, at this point now, if I wanted to solve for another angle, I have a choice now. I could continue to use the cosine law, but I also have a side angle relationship, A over the sine of A, and I could use sine law now as well. So I have some choices. Okay, let's do another example together. So on your next page of your notes, we're going to find a missing angle. So if we have to find a missing angle, that means we're going to be looking for either A, B, or C, okay, or an angle when we're using our cosine law, which requires us to rearrange the formula a little bit. It's also going to require us to eventually, at the end, take the inverse cos of whatever we get as our ratio. Okay, so whenever you're searching for an angle, you're always going to be taking an inverse ratio on your calculator. So let's do the last example, the last triangle that we had before. Okay, let's find a missing angle. So let's go ahead and draw our triangle again. Okay, it was triangle ABC, and it looked something like this. Okay, A, B, C. And we found that A was equal to 1.3 meters, and we were given C was 1.5 meters. We were also given angle A, which was a contained angle, and it was 59 degrees. Okay, and angle or side length B over here was equal to 1.0 meters. And so those are the values that we were given, and we found A. Okay, now you could use sine law here, but we're going to go ahead and use cosine law, particularly because we want to practice with it. Okay, so let's go ahead and we could find here either angle C or angle B. So we could find either of these. Okay, we could find either of these using cosine law. After we find one angle, the third angle will just be 180 degrees minus the other two angles. So that's fast and easy to find. Let's go ahead and just pick one. So let's pick angle B. Okay, let's go ahead and find that. So let's find angle B. Okay, we're going to use cosine law. And which one am I going to use? If I'm looking for angle B, which is right here, I have to use the cosine law that involves angle B, okay? And it will be the one where B squared is equal to the other sum of the other two angles squared minus 2AC times the cos of that angle. So I'm going to be using this one right here. Okay, this is what I will use. Now, you have a choice. You can plug in all the values that you have except the angle B, uh, and start your math that way, or you can rearrange your formula right away. Either of those options are totally acceptable. I'm going to go ahead and rearrange my formula so that I'm going to isolate the cos of B. Okay, so I want to isolate the cos of B, and remember that B is referring to angle B here. Okay, so I want to isolate the cos of B, so I'm going to rearrange my formula. So here's what I've got. B squared is equal to A squared plus C squared minus 2AC times the cos of B. And what I want to do here is I want to rearrange and just isolate this on its own. So the first thing I need to do is I need to move the A squared and the C squared over to the other side. Okay, in other words, you can think of that like exporting them over. Okay, you can move them to the other side and they become negative A squared, negative C squared. That's fine if you want to think of it that way. You can also think of it as I have to subtract A squared from both sides. So I have to subtract A squared from that side. Okay, and the other side. And I also have to subtract C squared from both sides so that we get rid of them on the right hand side. So we're going to do this step by step here. I'm going to get B squared minus C squared or minus A squared. Okay, doesn't matter the order, equals negative 2AC times the cos of angle B. I'm still trying to isolate cos of B, so I need to divide both sides by negative 2AC in order to get rid of that 2AC, negative 2AC that is being multiplied by the cos of B. So if I divide by that, okay, I'm going to cancel it on the right-hand side. So I get cos of B, let's just write this, we're just going to flip it around so that I have now cos of B on the right. So cos of B is equal to B squared minus C squared or minus A squared, doesn't matter the order here. I could say B squared minus A squared minus C squared divided by negative 2A times C. And on the bottom here, remember that 2A and C are all multiplied together. So we could put brackets around that to remind us in our calculators that we have to keep that together as a product. By rearranging it, now I just go ahead and plug in all the values that I have. Okay, so let's go ahead and do that. So B squared, okay, is side length B squared. So that's 1.0 meters squared minus C squared, side length C, 1.5, and I have to square that, minus A, side length A, 1.3, okay, squared, all divided by negative 2, okay, times A, which is 1.3, and I don't square it in this part of the formula, times C, which is 1.5. Okay, and on the bottom here, let's put some big brackets around that. We have to keep those together. So when you're doing this in your calculator, it's really important that you keep negative 2 times 1.3 times 1.5 together as a product. So go ahead and we're going to figure that out. Okay, so I take 1 squared minus 1.5 squared minus 1.3 squared. Okay, and let's see here. Altogether are, let me do this in 2 steps for you just so that you can be checking your work as you do it. Okay, so we get negative on the top, negative 2.94. Okay, divided by, on the bottom, we have negative 3.9. Okay, negative 3.9 on the bottom. So our answer is this. Cos of B is equal to, well, negative divided by negative, those are going to cancel. Okay, so my answer is positive. And 2.94 divided by 3.9 is going to give us 0.7538. That's what the cos of B is. I want to find the angle B, and so I'm going to go ahead now. If I come over here for a minute, okay, and I want to find the angle, not the ratio of the cos of B. And so if the cos of B equals that, then B, angle B, is equal to the inverse cos of 0.7538. Okay, so on our calculators, we take the inverse cosine of that, and that's going to come out to be 41 degrees. Okay, rounded to the nearest degree. 41 degrees is our answer. And we could actually, it's 41.07. So actually, let's go ahead and be just because we're going to find another angle, let's put that to one decimal place. So that's going to be 41.1 degree. So we'll be consistent and have one decimal place there just to be a little bit more accurate. Okay, finally then, angle C would be really easy to find. I don't have to use the cos law. I could, but I don't have to. Angle C, if this is 41.1 degrees, our missing angle is simply going to be 180 degrees, subtract the two that we know. So subtract 59 degrees, subtract 41.1 degrees. So angle C is going to be equal to 79.9, pretty close to 80 degrees. Okay, and there's our answer there for the third angle of our acute triangle. Great. Let's do one more example with finding an angle, particularly with the triangle that is not labeled ABC. Okay. So I've got a note here in your notes that says, if you need to solve for an angle, there's two choices that you have with cosine law. One is to plug in what you know, so plug in all the values, simplify your math, and then rearrange for cos of the angle. Or a fast and easy method here is to rearrange your cosine law first so that you have the cos of your angle equals a formula on the right hand side, and then plug in the values that you know. So substitute after you rearrange. It really makes no difference, whatever you're more comfortable with. But remember, at the end, your answer is going to be the cos of your angle is equal to some number. This is a ratio. Okay? This ratio that you have here really is, if you had split that acute triangle into two right triangles, it's really the adjacent over the hypotenuse. And this is just a ratio. And so what you need to do here is to find an angle, you always have to take the inverse cosine of that number, that ratio that you get. Okay, so you're always doing second function cos on your calculators, and that's going to give you an angle in degrees, your answer. So make sure that you remember that. Okay, what you're getting is not your angle, and your ratio is usually, not more than 1, or it's less than 1 in most cases. So you aren't going to be having an angle that's less than 1 degree. That is not something rational that we'll see. Okay, that would be an extremely small angle. So that should be a little bit of a common sense indicator to you that you have to do one more step. You have to take the inverse cos. Let's try this last one here. And actually, this is a triangle ABC, but that's okay. This is a side-side-side relationship that I have, so I don't have any angles at all. And which means whenever I have side-side-side, I have to use cosine law. I cannot use sine law here without any angles. And let's find angle B. So we're looking for this one right here. That's angle B. And I can see that if I label my sides right away, the side length across from angle B will be side length B, okay, which is equal to 20 inches, sorry, 20 feet. And A, side length A will be across from angle A, so here's my A. And finally, side length C is going to be 10 feet across opposite from angle C. So once I've labeled that, now I can go ahead and I can find my angle B. Okay, I'm going to be using B squared is equal to A squared plus C squared minus 2AC times the cos of angle B. And again, it makes sense for us to rearrange this formula first. So let's isolate the cos of B on its own. So in a quick step here, we're going to move A squared and C squared to the other side. So on the left-hand side, we're going to get B squared minus A squared minus C squared. Okay. And then I'm also going to divide by negative 2AC. Okay, so I'm doing this all in one step here. So cos of B is equal to B squared minus A squared minus C squared divided by, all on the bottom, negative 2AC. Okay, let's go ahead and substitute in our values that we're given now. So we know B squared, it's equal to 20. Okay, so 20 feet, and we're going to square it. Okay, minus A squared, and A is equal to 19.5. Okay, and we're going to square it. And that is, if I look at this is 19.5 feet. It's not 19 feet 5 inches. Okay, so that's okay to leave it as 19.5 here. And minus C, which is 10. Okay, squared, divided by, altogether on the bottom here, we have negative 2 times times 19.5. Times 10. That's equal to the cos of angle B. Okay, so go ahead and we do that math. And on the top, I'm going to get negative 80.25 divided by negative 390. And that's equal to the cos of B. And so a negative divided by a negative is going to give me a positive answer. And I get 0.2058 equals the cos of B. I'm almost done. What I do want is just angle B here. So angle B is equal to the inverse cos of 0.2058. So I take the inverse cos of my ratio, and angle B is going to come out to be equal to 78 degrees. Okay, 78 degrees. There's my answer. And so 78 degrees, I can go ahead and put that into my triangle now, 78 degrees. Okay, and at this point, if I wanted to solve the rest of the triangle, it's up to me whether I want to use cosine law. I could also use sine law now because I have a side angle relationship, and then I'm given the other two sides, so I could quickly find angle C or angle A, and then the third angle I can find simply by using the law that 3 angles in a triangle equal 180 degrees. Okay, the very last question that we'll do here together is just to sketch a triangle, because this is always really useful. It's working backwards. Okay, so on the bottom of your notes here, you have one last question. Sketch a triangle based on this equation. This is cosine law. W squared equals 15 squared plus 16 squared minus 2 times 15 times 16 times the cos of 75 degrees. Let's pick, we are given one side, so W. So let's call this triangle. Well, let's pick 3 letters to label our triangle. That one of those letters must be W. So let's call this WXY. You know, it doesn't really matter what 3 letters you use. Okay, well, now if I know this is triangle WXY, what I know is true about my law is that it would look like this. This is going to be W squared, okay, is equal to X squared plus Y squared minus 2xy times the cos of always the angle across from the side in the beginning of your formula. Okay, the side that you're solving for. So this is going to be angle W. So I know that angle W is equal to 75 degrees in this triangle. Okay, I also know that side length X is 15 and side length Y is 16. So I could go ahead and sketch my triangle now. So I have a 75-degree angle. Okay, so that looks maybe something like this. It's a little bit less than 90 degrees. So I could start here, and that's angle W. Okay, and if I come down over here on the left-hand side to vertices Y, X, Y, or WX, or that could be X, doesn't really matter. Okay, make that X. Okay, what I know about X is it's 15. Okay, so this is going to be side length 15. And I know that side length, oh, sorry. Apologize, folks. I'm not doing a good job here today. If this is going to be, here, let's go ahead and just complete our triangle here for a minute. We'll call this Y over here. Okay, so this is side length Y across from angle Y, and that's going to be 16. Okay, and it's supposed to be slightly longer than side length X, so we'll just make it a little bit longer, and there's 15 over here. There's side length X. Okay, and we can go ahead and connect our triangle now. Okay, so if I label it, this is X across from angle X, and Y will be 16 across from angle Y. And there's my triangle. Okay, all I'm asked to do is sketch it. I don't have to go any further here. Okay, and side length W would be over here, right across from angle W. Okay, I don't have to solve anything, just sketching it. So you don't always have to have an ABC triangle. You just have to think a little bit about your cosine law is always the same. Okay, the side length that's been isolated, so W in this case, it's going to be across from the angle in which we're taking the cosine of. So the angle here, 75 degrees, has to be angle W. It has to be the opposite. It's a side angle relationship here. So it's got to be angle W. And then the other two lengths, 15 and 16, have to be my other two side lengths in my triangle. Okay, I'd like you to try some questions yourself here. So on page 137, numbers 1 to 6, 7, A and C only. And you can check your answers in the back of the textbook. Thanks for joining me. Bye for now.